When given the slope and the y-intercept, you can write the equation of the line by substituting into slope-intercept form, which we've seen before. It's y equals mx plus b. If you're given a point and a slope, on the other hand, you can also write the equation of the line in what's called point-slope form. Point-slope form is y minus y1 equals the slope m times x minus x1. That's where x1 and y1 would be the coordinates of the point, and m, as you know, is the slope. So once again, point-slope form for the equation of a line is y minus y1 equals m times x minus x1. The x1, the y1 would be the coordinates of the point, and m would be the slope of the line. So we've seen slope-intercept form before. It's y equals mx plus b, where m is the slope and b is the y-intercept. Now we're looking at point-slope form, y minus y1 equals m times x minus x1, where x1, y1 would be the coordinates of the point, and m would be the slope of the line. A line passes through the point negative 5, 2 with a slope of 3/5. What is the equation of the line in slope-intercept form? So we're given a point, negative 5, 2, with a slope of 3/5. Need to get the equation of the line, and the final equation needs to be in slope-intercept form. So if you're given a point and a slope, you can use the point-slope form, y minus y1 equals m times x minus x1. The coordinates of that point, negative 5, 2, those are going to be substituted in for x1 and y1. Negative 5 goes in for x1, and 2 goes in for y1. And then the slope of 3/5, of course, that goes in for m. So if you substitute in, you have y minus 2 equals 3/5 times x minus a negative 5. Watch your signs. Now we have to start getting that in slope-intercept form. So as soon as you substitute into point-slope form, since our final equation needs to be in slope-intercept form, that's the direction we need to head. So x minus a negative 5, you can clean that up. Two negatives make a positive, so it'd be x plus 5. Y minus 2 equals 3/5 times x plus 5. Use distributive property with the 3/5 to get rid of the parentheses. 3/5 times x is 3/5 x, and 3/5 times 5, that would be 3. Now slope-intercept form is y equals mx plus b, so we have to solve this equation for y. To do that, add 2 to both sides. And if you add 2 to each side, you have y equals 3/5 x plus 5. That is the equation of the line in slope-intercept form that passes through the point negative 5, 2 with a slope of 3/5. If you want to check that, put 2 in for y and negative 5 in for x, and that will make a true statement. Both sides will equal each other. What is the equation in slope-intercept form of the line that passes through the point 7, negative 1 with a slope of negative 3? So again, you're given a point and a slope. We're going to use the point-slope form. 7, negative 1, the coordinates of the point, those go in for x1 and y1. So 7 goes in for x1, and negative 1 goes in for y1. So you have y minus a negative 1 equals negative 3 times x minus 7. Negative 3 is the slope. We need to start getting this in slope-intercept form. As soon as you substitute into point-slope form, we're heading towards slope-intercept form, y equals mx plus b. Minus a negative, that becomes plus. Also, you can use the distributive property with the negative 3. So it'll be y plus 1 equals negative 3x plus 21. Watch your signs again. You need to solve that for y to get it in slope-intercept form. So subtract 1 from each side. And we end up with y equals negative 3x plus 20. That is the equation of the line that passes through the point 7, negative 1 with a slope of negative 3. A line passes through the points 3, 2, and 5, 8. What is the equation of the line in slope-intercept form? So this time you're given 2 points. We need to get the equation of the line that goes through those 2 points. So to get the equation of the line, you need a point and a slope. We're given 2 points and no slope. So we need to find the slope of the line that goes through those 2 points. Remember, to find the slope of the line, don't rely on the formula. Just find the change in y over the change in x, also known as rise over run. Rise is the change in the y coordinates. Run is the change in the x coordinates. So to find the change in y over change in x, you can take 8 minus 2 over 5 minus 3, or you could go 2 minus 8 over 3 minus 5. So it doesn't matter which point you start with, just make sure you go back to that point when you're finding the change in x. So if we go 8 minus 2 over 5 minus 3, 8 minus 2 on top is 6, 5 minus 3 on the bottom is 2. 6 over 2, that'll reduce to 3. So the slope of the line that goes through those 2 points is 3. Now to get the equation of the line, we're going to go back to those 2 points and pick one. It does not matter which point you choose. Either point will work because we're getting the equation of the line that goes through those 2 points. So it doesn't matter which point you choose. We're going to use one of those points along with the slope. Now when choosing your point, a little bit of advice, stay away from big numbers, stay away from fractions, stay away from negatives. Pick the point that has the easiest numbers to work with. So in this case, I'm going to go with the 3, 2, just because it's smaller numbers than the 5, 8. Less chance of making a mistake. So I'm taking the point 3, 2 with the slope of 3 and substituting into point slope form. 3, 2, those are the x1, y1. So 3 is going to go in for x1, 2 is going to go in for y1. So it'll be y minus 2 equals the slope, which is 3, times x minus 3. We want to get that in slope-intercept form. So as soon as we substitute into point-slope form, we're starting to head towards slope-intercept form, y equals mx plus b. So get rid of the parentheses with distributive property with the 3. Take 3 times x, that is 3x, and 3 times negative 3 would be negative 9. To get that in slope-intercept form, you need to solve for y. So you need to move that negative 2 to the other side, add 2 to both sides. And if you do that, get y equals 3x minus 7. So that is the equation of the line in slope-intercept form that passes through these 2 points, 3, 2, and 5, 8. If you want to check that, substitute 3 in for x, 2 in for y, you'll get a true statement. Both sides will equal each other. Or you can substitute 5 in for x, 8 in for y, and again you get a true statement. Both sides will equal each other because those 2 points lie on the graph of that equation. So those 2 points, when you substitute the coordinates in, that will make a true statement. Y equals 3x minus 7 is the equation of the line that passes through those 2 points. You need to write an equation of the line in slope-intercept form that passes through the points 3 halves, negative 1 half, and negative 2/3, 1/3. A lot of fractions there. We're given 2 points. We need to get the equation of the line. To get the equation of the line, we need a point and a slope. If we're given 2 points, we can get the slope of the line that goes through those 2 points by finding the change in y over the change in x. So the change in the y coordinates over the change in the x coordinates. So to find the change in y, I'm going to take 1/3 minus a negative 1 half. And to find the change in x, negative 2/3 minus 3 halves. On top, 1/3 minus a negative 1 half minus a negative, that becomes plus. So that'd be 1/3 plus 1 half on top. And on the bottom in the denominator, negative 2/3 minus 3 halves, nothing changes there. We have fractions within a fraction. Now here's a little tip. To get rid of fractions within a fraction, multiply the numerator and denominator by the least common denominator of all those terms. So the least common denominator of 3, 2, 3, and 2 is 6. So we're going to multiply the numerator and denominator, top and bottom, by 6. That 6 is going to cancel with each one of those denominators. And what it's going to do is eliminate all of those denominators. So take 6 times 1/3. A third of 6 is 2. 6 times 1 half. Half of 6 is 3. Then take 6 times negative 2/3. That'd be negative 4. And 6 times negative 3 halves. That is negative 9. So in the numerator, 2 plus 3 is 5. In the denominator, negative 4 minus 9. That is negative 13. So you have negative 5/13. That is the slope of the line that goes through those 2 points. So we know the slope. We have to go back and pick one of those points. There's really not much of a choice there. One's just as bad as the other one because you have negatives involved, you have fractions involved. You're just going to have to pick one. So we're going to pick one of those points. It does not matter which point you choose. I'm going to use the slope with one of those points in point slope form. I'm going to go with the second point, negative 2/3, 1/3. Substitute that in for x1, y1. So negative 2/3 goes in for x1, and 1/3 goes in for y1. And the slope, which we have down here, negative 5/13, that goes in for m. Now we need to get this in slope-intercept form, so we have to get this in the form of y equals mx plus b. In other words, we need to solve this for y. You have a little work to do before that. X minus a negative 2/3, that is x plus 2/3, because minus a negative makes a plus. Get rid of the parentheses. Use the distributive property with the negative 5/13. Take negative 5/13 times x, it's negative 5/13 x. And negative 5/13 times 2/3 would be negative 10 over 39. Now again, to get this in slope-intercept form, we need to solve for y, so that negative 1/3 needs to be moved to the right side. To move that, we're going to add 1/3 to each side. And if you do that, we end up with y equals negative 5/13 x plus 1/13. That is the slope of that is the equation of the line that goes through these 2 points. It has a slope of negative 5/13, and it will pass through these 2 points. Y equals negative 5/13 x plus 1/13. So as far as forms for equation of a line, we've dealt with slope-intercept form. It's y equals mx plus b, where m is the slope and b is the y-intercept. Then we just looked at point-slope form. Y minus y1 equals m times x minus x1, where the x1, the y1, those are the coordinates of the point, and m is the slope. Now we're going to talk about standard form. Another form for the equation of a line is standard form, in which the sum of the x and y terms are set equal to a constant term, a number without a variable. The coefficients of x and y and the constant are written as integers. In other words, no fractions nor decimals, when possible. So standard form of a linear equation is ax plus by equals c. Now the a, b, and c, those will soon be numbers. A, b, and c are written as integers, not fractions nor decimals, when possible. So we're going to take this equation, y equals 3/4 x minus 5, and we're going to get this in standard form with integer coefficients. In other words, no fractions or decimals. Standard form, again, with that, the x and the y are on the left side, the constant term is on the right side. So we need to get the x and the y to the left side, and the constant term will stay to the right side. To get that in standard form, you need to move the 3/4 x to the left side. To do that, we're going to subtract 3/4 x from each side. And we have negative 3/4 x plus y equals negative 5. Now remember, no fractions or decimals. So to get rid of the fraction, the only fraction there is 3/4. To get rid of that, we're going to multiply the entire equation by the the only denominator there. Usually it's the least common denominator if you have more than one fraction, but the only denominator there right now. Now you could multiply by 4 or negative 4. So if you take the entire equation by 4, you're going to multiply each term by 4. If you take 4 times negative 3/4 x, that would just be negative 3x. 4 times y is 4y. And 4 times negative 5, that would be negative 20. So notice the x and the y are on the left side. The constant term, the number without the variable, is on the right side. That is standard form. That's standard form for the equation of this line. So we started in slope-intercept form, y equals 3/4 x minus 5. We got the x and the y to the left side, the constant term to the right side. Also got rid of the fraction that was in place there. Negative 3x plus 4y equals negative 20. What is the equation of the line y equals 9.1x plus 3.6 in standard form? So in standard form, you can't have any fractions or decimals. You need to get rid of the fractions or decimals. And you also need to get the x and the y to the left side. The constant term will stay on the right side. So first thing we're going to do is move that 9.1x to the left side by subtracting 9.1x from each side. You get negative 9.1x plus y equals 3.6. But now we have to get rid of the decimals. So to get rid of the decimals, if you remember back from elementary school, you talked about your decimal places. You had tenths place, hundredths place, thousandths. You're going to look at the digit that's farthest to the right after the decimal point, and that's what you're going to multiply by as far as 10, 100, or 1,000. Now these are both in the tenths place, but if one of them, let's say this was 3.65, that last digit would be in the hundredths place. You'd have to multiply by 100. So you always multiply by the digit that's farthest to the right. That will eliminate the decimals. So in this case here, not a big deal. Each one of these, the digit to the right after the decimal point's in the tenths place, we're going to multiply the entire equation by 10, and that will eliminate the decimals. Because what's happening there is you're moving the decimal point to the right one place if you're multiplying by 10. If you had, if you had a digit that was in the hundredths place and you multiplied by 100, that would move the decimal point to the right 2 places. But here we just have to move to the right 1 place. So 10 times negative 9.1x, that is negative 91x. 10 times y is 10y. And 10 times 3.6, just moving the decimal point to the right 1 place, that is 36. So that is this equation, y equals 9.1x plus 3.6 in standard form. We got rid of the decimals. We also moved the x and the y to the left side. The constant term is on the right side. That is standard form. Negative 91x plus 10y equals 36. Just a little review of equations of lines, forms for the equations of lines. Slope-intercept form is y equals mx plus b. That's where m is the slope and b is the y-intercept. You use that when you know the slope and the y-intercept. Simply substitute into slope-intercept form, and that will give you the equation of the line. Point-slope form, y minus y1 equals m times x minus x1. Going to use that if you know a point and a slope. All you need is 1 point, 1 slope, and you can get the equation of the line. Y minus y1 equals m times x minus x1. x1 and y1, those are the coordinates of the point, and m is the slope. And then standard form, it's kind of like the finishing touch. Some textbooks or teachers may ask you to put your final equation in standard form. But remember with that, the x and the y are on the left side, the constant term is on the right. Also, no fractions nor decimals. Slope-intercept form, point-slope form, those are the working forms that you substitute into to get the equation of the line. And then standard form, it's kind of like the finishing touch or the wax job on a car. Some teachers or books may ask you to put your final equation in standard form. Those are the three forms for the equation of a line. Back in pre-algebra, Algebra 1, you may have graphed equations by making a chart where you have x on the left and y on the right. You put numbers in for x, you get out y values. Then you have a set of points, you put those on the graph, and then you draw a line through those points. You want to try to get away from that because there are quicker, more efficient ways to graph, such as slope-intercept form, which we've seen. When you have an equation in slope-intercept form, you see the y-intercept, you see the slope. So to graph it, you put a point at the y-intercept and then move accordingly using the slope to get another point. So then you have 2 points and you draw a line through those 2 points. So you start with the y-intercept, use the slope as rise over run, put another point down, and then draw a line through those 2 points. So you can graph out of slope-intercept form using that. And you can also graph out of standard form. The equation in standard form can quickly be graphed by determining the x-intercept and the y-intercept and then drawing a line through those 2 points. At the x-intercept, one thing to note is that the value of y is 0. So if you wanted to get the x-intercept, just substitute 0 in for y. At the y-intercept, the value of x is 0. So if you wanted to get the y-intercept, you don't have to get it in slope-intercept form. To see the y-intercept, just substitute 0 in for x. So at the x-intercept, the value of y is 0. At the y-intercept, the value of x is 0. So let's say we have an equation 2x minus 3y equals 5, which we're going to use this in a little bit. You can get the x-intercept by substituting 0 in for y, and you can get the y-intercept by substituting 0 in for x. If you put 0 in for y, this would disappear. You just have 2x equals 5. And if you put 0 in for x, this would disappear. You'd have negative 3y equals 5, and then you can solve each one of those accordingly for the x and the y. So we're going to take that equation we just had and we're going to graph that. Now that's in standard form. We are going to graph out of standard form. 2x minus 3y equals 5. We're going to graph this by getting the intercepts, the x-intercept and the y-intercept. Remember, to get the x-intercept, we're going to substitute 0 in for y because at the x-intercept, where the line of the graph crosses the x-axis, the value of y is 0. So if we substitute 0 in for y and solve that for x, that will be the x-intercept. If you substitute 0 in for y, negative 3 times 0, that's gone. It disappears. You have 2x equals 5. If 2x equals 5, divide each side by 2, then x equals 5 halves. So the x-intercept is 5 halves. The coordinates would be 5 halves, 0. So you can put a point at 5 halves, 0, or 2 and 1 half, 0 is what that is. But you also need to find the y-intercept. We need 2 points to make a line. So to find the y-intercept, we're going to put 0 in for x, because at the y-intercept, where it crosses the y-axis, the value of x is 0. So if you substitute 0 in for x, that'll be gone. You're going to have negative 3y equals 5. If negative 3y equals 5, divide each side by negative 3. If you divide each side by negative 3, y is going to equal negative 5/3. That is the y-intercept. That's where the graph crosses the y-axis. Coordinates of that point would be 0, negative 5/3, because x is 0, y is negative 5/3. So put a point at negative 5/3, which would be negative 1 2/3. We have that point at 5 halves, or 2 and 1 half, on the x-axis. So the x-intercept is 5 halves, the y-intercept is negative 5/3. Draw a line through those 2 points, and that is the graph of that equation. 2x minus 3y equals 5. What are the intercepts of 2x minus 4y equals 8? And then graph the equation. So we're going to find the x-intercept and the y-intercept, draw a line through those 2 points, and we'll have the graph of the equation. To get the x-intercept, we're going to substitute 0 in for y, because at the x-intercept, where the graph crosses the x-axis, the value of y is 0. You're not up or down any. You're right on the x-axis, y is 0. So substitute 0 in for y, you end up with 2x equals 8. If 2x equals 8, divide each side by 2, then x is equal to 4. That is the x-intercept. So put a point at 4 on the x-axis. To get the y-intercept, we're going to substitute 0 in for x, because at the y-intercept, where the graph crosses the y-axis, the value of x is 0. You're not left or right any. You're right on the y-axis, and that's where the value of x is 0. So to get the y-intercept, substitute 0 in for x. If you do that, 2 times 0, that's gone. That's just 0. You have negative 4y equals 8. Then divide each side by negative 4. Y equals negative 2. So the y-intercept is negative 2. The coordinates of that point would be 0, negative 2, because x is 0. So put a point at negative 2 on the y-axis. We have that point at 4 on the x-axis, and then draw a line through those 2 points. Now compare that method to back in pre-algebra, algebra 1, where you made those charts, you put numbers in for x, you got numbers in for y, and then you had to plot all those points. Just 2 points is all it takes. We just put a 0 in for x, a 0 in for y, and that's all it took. Pretty easy. Parallel lines. Lines that are parallel are equal distant throughout. So as these lines go on forever, they're the same distance apart. The thing about parallel lines is they have the same slope. That's one thing to remember, is parallel lines have equal slopes. The change in y over the change in x, the rise over the run, vertical change over the horizontal change, it's the same for both lines. You can see those lines are equal distant, they are parallel lines, and they do have the same slope. Perpendicular lines, on the other hand, so lines that come together to form right angles or 90-degree angles, they have slopes which are called negative reciprocals. So let's say the slope of one of these lines is 3/2. The negative reciprocal of that would be negative 2/3. So you take the negative of 3/2, flip it over, that's taking the reciprocal, and you have negative 2/3. Or if you started with negative 2/3, if that's the slope of one of the lines, the negative reciprocal of that, take the negative of it, becomes positive 2/3, flip it over, and it becomes 3/2. So perpendicular lines have slopes which are negative reciprocals. Parallel lines have equal slopes. What is the slope of a line that is parallel to a line that passes through the points negative 2, negative 1, and negative 4, 2? Well, if you're looking for the slope of a line that is parallel to this line, it's going to be the same. So if we find the slope of the line that goes through these 2 points, the line parallel to that will have the same slope. Remember, to find the slope of the line, you don't need the formula. Just find the change in y over the change in x. Subtract the y coordinates, put that over the subtraction of the x coordinates. So you could go 2 minus negative 1 over negative 4 minus negative 2. Or you could go this way, negative 1 minus 2, that's a change in the y coordinates, over negative 2 minus negative 4. Either way you do it, you end up with the same slope. So there's the formula. You really don't need that. Just find the change in y over the change in x. So we could go 2 minus negative 1 over negative 4 minus a negative 2. 2 minus a negative 1 on top, that'd be 2 plus 1, that's 3. And negative 4 minus a negative 2 on the bottom, that's negative 4 plus 2, which is going to end up being negative 2. So we end up with 3 over negative 2. The whole fraction is negative, doesn't matter where you write the negative sign. Could be on the top, the middle, in other words, off the side or the bottom. That whole fraction is negative. The slope is negative 3/2. Remember, we want the slope of the line that is parallel to this one. Well, if this line has a slope of negative 3/2, the line parallel to that will also have a slope of negative 3/2. What is the slope of a line that is perpendicular to a line passing through 4, negative 1, and negative 3, 5? So we want to get the slope of the line that goes through these 2 points, and then find the slope that is perpendicular to that one. To find the slope of the line, we're going to find the change in y over the change in x. Take 5 minus a negative 1 over negative 3 minus 4. Or you could go negative 1 minus 5 over 4 minus a negative 3. Either way, you're going to get the same slope. Change in y over change in x. So 5 minus a negative 1, it's going to be 5 plus 1, that's 6. Negative 3 minus 4 in the bottom, it's going to be negative 7. So 6 over negative 7, or negative 6/7. Again, it doesn't matter where the negative sign is. The slope of that line is negative 6/7. We need the negative reciprocal of that, because we're looking for the slope of a line that is perpendicular to that one. So take that slope, negative 6/7, flip it over, and take the negative of it. So if you take the negative of negative 6/7, it turns positive. And if you flip that over, it becomes 7/6. So the perpendicular slope would be 7/6. You need to write the equation of a line in slope-intercept form that is parallel to y equals 6x minus 2. So it's going to have the same slope as that. And also passing through the point 1, negative 3. Remember, to get the equation of the line, we need a point and a slope. We have the point, and we're going to get the slope. So that given line, y equals 6x minus 2, we're going to get the slope of that line, and it's right there because that's in slope-intercept form. You can see the slope is 6. So we're going to take that slope of 6 and this point 1, negative 3 and get the equation of the line that passes through this point and has this slope. So we want to get the equation of the line that is parallel to this line, same slope, slope is 6, and passing through this point 1, negative 3. So the point is 1, negative 3, the slope is 6. Remember, when we substitute the point in, that's going in for x1, y1. 1 goes in for x1, negative 3 goes in for y1. The slope, which is 6, that goes in for m, into point slope form. So y minus negative 3 equals 6 times x minus 1. Minus a negative becomes plus, that'd be y plus 3. Use distributive property to 6, becomes 6x minus 6. We need to get this in slope-intercept form. So right after we substitute into point-slope form, we're heading towards slope-intercept form. We need to solve this for y, subtract 3 from each side. If you do that, you have y equals 6x minus 9. That is the equation of the line that is parallel to this line. They have the same slope. The slope is 6 on each one, and it's passing through this point, 1, negative 3. If you wanted to check to see if it's passing through that point, 1, negative 3, substitute negative 3 in for y, 1 in for x, and you get a true statement. Both sides equal each other. Y equals 6x minus 9. We're going to write the equation of the line in slope-intercept form that is perpendicular to y equals 2/3 x minus 1 and passing through the point 0, 6. Remember, to get the equation of the line, we need a point and a slope. We have a point on the line that we want, that's 0, 6, but we don't know what the slope is yet. We're going to get that. So take that equation, y equals 2/3 x minus 1. Pick out the slope on that. The slope on y equals 2/3 x minus 1 would be this 2/3, but we want to be perpendicular to that. So being perpendicular to that, having a slope of 2/3, we'd have to take the negative reciprocal. So to get the negative reciprocal of 2/3, flip it over, take the negative of it. So if you flip that over and take the negative of it, you end up with negative 3/2. So the line that we want has a slope of negative 3/2. It's perpendicular to that one, and it's passing through the point 0, 6. So there's our point, and there's our slope. So using point-slope form, the point, coordinates x1, y1, 0 goes in for x1, 6 goes in for y1, and negative 3/2 goes in for the slope. So you have y minus 6 equals negative 3/2 times x minus 0. Get rid of the parentheses, use the distributive property, take negative 3/2 times x. Negative 3/2 times 0 is just going to be 0. So y minus 6 equals negative 3/2 x. Then add 6 to both sides to get that in slope-intercept form. You have y equals negative 3/2 x plus 6. You really didn't need to go through all that work. Back here, with this point being 0, 6, notice the x-coordinate is 0, and the y-coordinate is 6. When the x-coordinate is 0, that's the y-intercept. So if you had the slope, that's the y-intercept. Notice down here, the slope is negative 3/2, and the y-intercept is 6. So we could have went from that straight into slope-intercept form. Because with the point of being 0, 6, with x being 0, 6 is the y-intercept, negative 3/2 is the slope. Y equals negative 3/2 x plus 6. For the linear equation, x minus 2y equals 10, which of the following has a value of 10? There's some different ways you can go about this. You could substitute 0 in for x, and give you the y-intercept. You could put 0 in for y, and give you the x-intercept. If you get it in slope-intercept form, you can see the slope and the y-intercept. Probably not going to be the origin, so you could throw that one out from the beginning. Let's take this and get it in slope-intercept form. To get this in slope-intercept form, we need to solve this equation for y. So to solve that for y, move the x to the other side. You have negative 2y equals negative x plus 10. Then divide the entire equation by negative 2. If you divide each term by negative 2, you have y equals 1/2 x minus 5. So there you can see the slope and the y-intercept. None of those are 10. So the slope is 1/2, the y-intercept is negative 5. You can start ruling out answers. Slope is not 10, and the y-intercept is not 10. We know it's not the origin. So just by process of elimination, we can see that the x-intercept is 10. Another way you could have gotten that, put 0 in for y, that'll give you the x-intercept. So if you substitute 0 in for y, the x-intercept, x, will end up equaling 10, and the answer then is definitely letter B. Which represents the slope of a line that is parallel to a line with a slope of negative 2. So we want to be parallel to a line that has a slope of negative 2. Remember, parallel lines have equal slopes. They have the same slope. So if we want to be parallel to a line with a slope of negative 2, the new line will also have a slope of negative 2. Letter H. Which equation represents a line through the point negative 2, 1 that is perpendicular to y equals negative 5x plus 2. So we need to get the equation of the line that passes through the point negative 2, 1 and is perpendicular to this line, y equals negative 5x plus 2. Remember, to get the equation of the line, we need a point and a slope. We have our point right there. I'm going to use this line to get the slope because we're perpendicular to that line. Perpendicular lines have slopes that are negative reciprocal. So if you take this given line, y equals negative 5x plus 2, you can see the slope is negative 5. But that's not the slope we want. We want to be perpendicular to that. So perpendicular lines have slopes that are negative reciprocals. Take that negative 5, take the negative of it, and flip it over. That's taking the negative reciprocal of negative 5, which would be positive 1/5. So there's our slope, 1/5. The point is negative 2, 1. We're going to substitute those into point slope form. Remember the coordinates of the point, that's going to go in for x1 and y1. Negative 2 goes in for x1, and 1 goes in for y1. And then this 1/5, that's going to go in for the slope. So if you substitute in, we have y minus 1 equals 1/5 times x minus a negative 2. Clean that up, x minus a negative 2, that becomes x plus 2. And then use the distributive property to get rid of the parentheses. 1/5 times x, that is 1/5 x. And 1/5 times 2 would be 2/5. Now, notice these answer choices are all in slope-intercept form. So as soon as we substitute into point-slope form, we're going towards slope-intercept form. To finish this off, get this in slope-intercept form, need to move that negative 1 away from the y by adding 1 to both sides. If you add 1 onto 2/5, you're adding 5/5. That's 1 onto 2/5, and that would be 7/5. Y equals 1/5 x plus 7/5. That's the equation of the line that passes through the point negative 2, 1. And is perpendicular to that line, y equals negative 5x plus 2. Letter A, y equals 1/5 x plus 7/5. Which equation represents the line going through the point negative 1, 1 with a slope of 2/3? Notice the answer choices are all in point slope form. So all we have to do is substitute into point slope form the coordinates of the point and the slope. Point slope form, y minus y1 equals m times x minus x1. I'm going to substitute negative 1 in for x1, 1 in for y1, and this 2/3 in for m, the slope. So if you do that, you have y minus 1 equals 2/3 times x minus negative 1. Remember the answer choices, we don't want to go to slope-intercept form here because these answer choices are all in point-slope form. So to get this finished off in point-slope form, x minus negative 1, that's x plus 1. So y minus 1 equals 2/3 times x plus 1. That matches letter F. Which of the following equations is shown on the graph? So which of these equations matches that line? Notice these equations are all in point-slope form. Y minus y1 equals m times x minus x1. The thing about point-slope form, though, is you can see the coordinates of one of the points. So x1, y1, those would be the coordinates of a point, and m is the slope. So we can take each one of these equations, look at them closely, and decide which point is showing up there. I'm going to start with letter A. If that's y plus 2, now remember point-slope form, you have to be careful of your signs. Point-slope form is y minus y1. So if that's showing up as y plus 2, that means the y coordinate would actually be negative 2. Because to make a y plus 2, you'd have to go y minus a negative 2. That would end up making y plus 2. So the y coordinate's negative 2, and for the x coordinate, x plus 2, in point-slope form, it's x minus x1. So to make x plus 2, you'd have to go x minus a negative 2. The x coordinate's negative 2, the y coordinate is negative 2. For letter B, y plus 3. To make a y plus 3 in point-slope form, you'd have to go y minus a negative 3. So the y coordinate is negative 3, and for x plus 6, the x coordinate would have to be negative 6, because to make an x plus 6, you'd have to go x minus a negative 6. That would make x plus 6. So the x coordinate's negative 6, the y coordinate is negative 3. Letter C, a little bit easier, because that's already y minus 3. So in point-slope form, y minus y1, if that's showing up as y minus 3, the y coordinate is 3, and the x coordinate would be 6, because that's showing up as x minus 6. X minus x1, if that's x minus 6, the x coordinate is 6. So the point is 6, 3 on letter C. And then letter D, same thing. Y minus 2, the y coordinate would be 2. And x minus 2, the x coordinate would be 2. Remember, y minus y1, if that's y minus 2, the y coordinate is 2. And x minus x1, if that's x minus 2, the x coordinate is 2. Now notice all of these lines have slopes that are -1/2. So the slope isn't going to help us much here, but these points surely will. So decide which of these points lies on the graph of that equation. If you look at the point 2, 2, that is on that line. So letter D is the correct answer. That contains the point 2, 2. 2, 2 lies on this line, and also that line has a slope of -1/2. Letter D is it. The line y equals 5/9 x plus 6 is graphed on a coordinate plane. A second line is drawn on the same plane with a slope of -5/9 and a y-intercept of 0, -6. Write the equation of the second line and then describe the relationship between these two graphs. There's a couple ways you can get the equation of that second line. One way is, since you're given a slope of -5/9 and a point of 0, -6, given a point and a slope, you could use point-slope form. Not saying this is the easiest way, but that is one way to do it. So in point-slope form, y minus y1, that would be y minus a -6. And then that equals m, which is -5/9 times x minus x1, that would be x minus 0. I'm going to get that in slope-intercept form. So y minus -6, that is y plus 6. -5/9 times x minus 0, it's just going to be -5/9 x. And then to get it in slope-intercept form, subtract 6 from each side. Y equals -5/9 x minus 6. So there are the two lines. Y equals 5/9 x plus 6, and y equals -5/9 x minus 6. So the equation of that second line would be y equals -5/9 x minus 6, but we need to describe the relationship between these two graphs. What do they have in common? Well, looking at them, they don't look perpendicular. They're definitely not parallel. So the only thing they do have in common is that, and that is the same x-intercept. I want to go back to getting the equation of this line. An easier way to get this equation is looking at this point 0, -6. If the value of x is 0, that's the y-intercept. So you have this slope of -5/9. You have the y-intercept of -6. You can just substitute into slope-intercept form. Y equals mx plus b. Put -5/9 in for m, and -6 in for b. That is slope-intercept form. We could have skipped all of this work here. But the equation is y equals -5/9 x minus 6. And what do those two lines have in common? They have the same x-intercept.